Good morning, students. Myself, Vijay Shankar from ECE Department, Chevrolet Engineering College. Today, we are going to discuss about the examples in magnetostatics. That is the fourth unit. In the last week, we completed up to the 3 units: transmission line 1, transmission line 2, and also the third unit, electrostatics. All the examples. Now you go for the magnetostatics, the fourth unit examples. The first one is find the incremental field strength. Find the incremental field strength at P2, nothing but is a point P2, due to the current element of 2 pi AZ bar microampere meter at P1. The coordinates of P1 and the P2 are given 400 and 030 respectively. Means 2 points is given. 1 point is a 4000, that is a P1, and P2 is a 030. And the element here, find the incremental field strength at the P2 due to the current element is given the 2 pi AZ bar microampere meter at the P1. Okay, see that P1 and the P2, the points X value is a 0 and the Z value is a 0, means a point on the Y axis, that is 030 here. Z axis and the Y axis, and here it is a X axis. And 400 means a point on the X axis, remaining Y and the Z is a 0. So we need to find from here the X axis because it is given in the P1, the P2 due to the element, current element of 2 pi AZ bar microampere meter. So the formula we have, the differential magnetic field strength I1 DL1 bar cross A R12 bar 12 here, 4 pi R12 square. It's a sending end and the receiving end here. So 0 minus 4 whole square, and 3 minus 0 and 0 minus 0. So AZ bar get cancelled here. R12, the distance. So 0 minus 4 AX bar is a minus 4 AX bar, and 3 minus 0, it's a AY bar. And here to find the base vector A R12 bar, you have to take the magnitude. Under root of 4 square is a 16 and 3 square is a 9. 25 under root of 25 is a 5. So we got the distance and the base vector also. Minus 4 AX bar and the 3 AY bar is a X bar, my dear students, and the AY bar by 5. And I1 DL1 bar is given as a 2 pi AZ bar microampere meter. Okay, I can substitute in the differential magnetic field strength by taking the cross product of base vector and I1 DL1 bar. The cross product here, the formula itself having the cross product is there. The cross product is AX, AY and the AZ bar, and it is a AZ bar, means the coefficient of AZ bar having got the 2 pi, and remaining 2 functions is a 0, 0 in the ideal bar. Here AZ bar coefficient is a 2 pi, so the 0, 0 and the 2 pi, because it's AZ bar, AY bar and the AX bar. And here AX bar coefficient is a minus 4 by 5 and the AY bar coefficient is a 3 by 5. And there is no any Z coefficient, 0. I can apply the AX bar term here, the 0 into 0, 0, 2 pi into 3 by 5 is a AX bar coefficient. So 2 pi into 3 by 5 is a minus, and to get it is a AY. Let us take these two functions, 0 into 0, 0, 2 pi into minus 4 by 5 whenever you can take the AY value, it is a minus of minus is a plus. Already we have a 0 into, not the 0, 2 pi into 4 pi is a minus, minus into minus here, the plus. And whenever you can take the AY value, you can take the minus. So both the functions having the minus is there. So I will explain here. Confusing AX bar and AY bar, AZ bar, IDL bar, the first you can take the 0, 0, 2 pi, and the minus 4 by 5, and the 3 by 5, and the 0. You need to find, apply the cross product here. AX bar multiplying here the 0 into 0, 0, minus 2 pi by 2 pi into 3 by 5. Okay, that is a AX bar minus AY bar into 0 into 0, 0, minus 2 pi into minus 4 pi. 2 pi into minus 4 pi. Okay. Then the last one, AZ bar plus AZ bar. AZ bar means you can take these two, 0 into 3 pi and 0 into this one, 0 minus 0. Okay. Now what is the AX bar coefficient? Now the AX bar coefficient is a minus 2, 3 pi, that is just 2 pi by 5, the 3 into, and AY bar coefficient here, internally there is a minus into minus is a plus, and again it is a minus here, minus AY bar into the 2 pi by 5 into 4. Okay, in these two functions, there is a 2 by 5 is a common, minus 2 pi by 5 is a common term. As of 3AX bar plus, already I take the minus is a common, 4AY. 4AY bar. So this is a function of IDL bar cross, DL1 bar cross, AR12 bar. So substitute this value here, and another one is there, DH2 bar is equal to by the 4 pi into 5 square. So I got the formula here. What is the formula saying that it is 4 pi r square. What is r under root 5? That is a 5 square. And I can keep that as a pi, 4 pi r12 square. The distance we got as 4 pi into 5 and whole square. Simplify this function, you'll get minus 4 into 10 power minus 3, 3AX bar plus 4AY bar, the microampere per meter. Micro here we have, micro is there. Got it, my students? The current there is a micro is there. So pi get cancelled, and here it is divided, that is a 2. Okay, and 5 will get in the denominator only, 25 into 5 into 2. Okay, the remaining is a 3AX bar plus 4AY bar is the same common term is there. You can write this as 3AX bar plus 4AY bar and divided with 5 cube into 2. Okay, let's simplify that one. We'll get here the minus is also there. Totally, it is a minus of the function. DH2 bar is a minus 12AX bar and minus 16AY bar. Nano ampere per meter. Why it is a nano? 10 power minus 3 is multiplied with the 10 power minus 6. we'll get as a nano 10 power minus 9. So 4 3 is a 12 and 4 4 is a 16. Got it, my dear students? And coming to the next one, next example. Say current filament carries a current of 10 amperes in AZ bar direction of on the Z axis. Find the magnetic field H bar at point 1, 2, 3 due to this filament if it extends from Z is equal to minus infinite to infinite one time and Z is equal to 0 to 5 meters and Z is equal to 5 to infinite. Express the answers the Cartesian coordinates. They are asking the three ways. So one is Z is equal to minus infinite to infinite. You can take the charge uniformly distributed on the Z axis from minus infinite to infinite here. Okay, this is a totally charge in the Z axis. And similarly, the second one is also on the Z axis only, but the range is 0 to 5 meters only. 0 to 5 meters. Okay, it is a 0 to 5 meters here. The axis starts from the origin and up to the 5 meters. This is a dark line shows on the Z axis is uniformly distributed. And similarly, the another one is a 5 meters to the infinite. So from 5 meters to the infinite here. The three different diagrams shown in this. One is from minus infinite to infinite, another one is 0 to 5 meters, and another one the 5 meters to the infinite. Okay, in the first case you can take it is infinitely long straight conductor. What is the formula? The field we know the I by 2 pi r into A phi bar is a formula, my dear students. We already derived this expression in the theoretical classes. H bar is equal to I by 2 pi r into A phi bar. What is the current given? The 10 amperes. And the point is given at 1, 2, 3. Point is given at the 1, 2, 3. And it is you have to find in the Cartesian coordinates they are asking. So 1, 2, 3. And because it is in the Z axis, the eliminating of Z component, only you can take the remaining 2 to find the R under root of x square plus y square. 1 square plus 2 square is a 4 under root of 5 meters. Substitute in the H bar as I is given the 10 amperes and the 2 pi R is under root of 5 A phi bar. Ampere per meter. H bar is equal to electric field is a volts per meter. To find the x components, take the dot product of with Ax bar. Hx is equal to H dot Ax bar. Hy is a H dot Ay bar. Because there is only the two components. There is no H Z component because they uniformly distributed on the Z axis we can take. So 0.707 A phi dot Ax. A phi dot Ax, it is a sin phi, my dear students. So that is a vector transformation. We already know that one vector transformation. A phi dot Ax is a sin phi, minus sin phi. So minus 0.7117 is a Hx code. And the Hy term is H dot Ay is a phi and the Ay dot product is a plus cos phi. Okay, that is a 0.7117 cos phi. My students. And we need to find the phi is equal to, because we are converting that conversions of a Cartesian to the spherical or the Cartesian to the cylindrical coordinate system. Phi is equal to tan inverse y by x. What is the y here? 2 term, and x the value is a 1, tan inverse 2 by 1. So 63.43 degrees for the point P. So Hx is equal to, you can substitute as a phi value as a phi is here the sine phi. Sine phi means the sine 63.43 degrees. Substitute and find the hx value. Similarly, the cos phi, cos 63.43 degrees, you'll get hy value. So totally the h bar is equal to having that as hx into ax bar plus hy into ay bar plus hz into az bar. So there is no any hz bar coefficient. We have only the two components. One is minus 0.6365 ax bar plus 0.3183 ay bar. So this is a h bar in amperes per meter. The first case when we consider as z is equal to minus infinite to the infinite value. Got my students. And the second case, is z is equal to 0 to 5 meters. 0 to 5 meters. So r is always the same because it is in the z-axis. So 1 plus 4 under root of 5 and alpha 1 and alpha 2 will get now. Because the finite length, it is not the infinite length, the finite length. Alpha 1 is equal to tan inverse of 3 by under root of 5. And alpha 2 is equal to tan inverse 2 by under root of 5. Y means it is a 2 and this one, you can split this as a part. 0 to 3 means here it is opposite side, the value is a 2. And here the opposite side, the value is a 3. And 0 to 5 is divided as up to this, the value is a 3 meters. And here the 2 meters. Okay, my dear students. So the alpha 1 and alpha 2 opposite side by the adjacent side and opposite side by the adjacent side. Adjacent side is a r on here. See, this the value is a r. R is a root 5. So alpha 1 is a 3 by root 5 as alpha 1. See here, alpha 1 up to the 0 to 3 is a 3 by 5 root 5 and here the 2 by root 5. 2 by root 5. The alpha 1 we got the 53.3 degrees and alpha 2 is 41.81 degrees. Okay. But the negative has ended below the point P. So why it is taking that is alpha 1 is a minus means the negative sign is point P, the below value only is alpha value. Point P is 1, 2, 3 here. And we can take it is a value is the below the value. So you can take the upward direction is a positive value and downward direction is a negative value. Got it, my students? And now, what is the formula for the infinite means I by the 2 pi r into a phi bar. But whenever if you take the finite length, the h bar is equal to I by 4 pi r into sine alpha 2 minus sine alpha 1 into a phi bar is a magnetic field h bar is equal. So I is a 10, 4 pi into under root of 5. Alpha 2 we got the 41.81 degrees. Alpha 1 is a minus 53.3 degrees. And sine of minus theta becomes of plus sine 41.81 degrees and plus sine 53.3 degrees. Find using the calculator, we get the h bar is equal to 0.522 into a phi. But in this h bar, we need to find the components of ax bar and ay bar. What is the components here? The hx and h1. In this case also, we are taking the hx and hy only. There is no the hz because the charges, the current is that is passing through the z-axis only, not the charges here. The magnetic field we are discussing. Okay, the conductor is on the z-axis. The first one is a long straight conductor, infinite length. Now we can take the same thing, the conductor from 0 to 5 meters. So h bar dot ax bar and ax and ay, the dot a phi and ax dot product is a minus sine phi and a phi dot ay is the cos phi. Phi value we already know, that is a tan inverse y by x. 63.43. The previous day also we did. Then Hx and Hy is equal to minus 0.4673 and Hy is a 0.2337. H bar is equal to, we'll get Ax bar and the Ay bar coefficient. And the third case, R is the same, root under x square plus y square, that is under root of 5. But Z is start from the 5 to the infinite. 5 to the infinite. The previous case, alpha 1 is equal, we can take the 2 by the R, and the alpha 2 is equal to tan inverse infinite by R. The 3 is there. You see now, the diagram shows here, alpha 1, the distance is 3 to the 5. 3 to the 5 here. Why I am taking the 3? Because the Z is equal to 3 here. The point, the previous case also, the Z is equal to 3 means the below the value, we can take the alpha 1 is equal to minus degrees. So now the alpha 1 is opposite side and the adjacent side is a R here. The 2 value is a 2 distance, because start from the 5 and the 3, 2, and from here onwards it is an infinite. So tan inverse tan alpha is equal to tan alpha 2 is equal to adjacent side is an infinite by R, and tan alpha 1 is equal to 2 by R. Then after we can take the alpha 1 is equal to tan inverse 2 by R, and alpha 2 is equal to tan inverse infinite by R. So what is the infinite by R? Tan inverse infinite means the pi by 2. And it is a 2 by root 5. You can find the value of alpha. Alpha 2 is 90 degrees. Okay. You can see alpha 2 the 90 degrees and 2 by root 5 is a 41.81 degrees. Substitute that in the H bar as of sin alpha 2 minus sin alpha 1 BA5 bar sin 90 minus sin 41.81 degrees. You'll get the 0.118635. Okay. We need to find the H bar having the Hx bar, Hx coefficient and Hy, X bar coefficient is Hx and Ay bar coefficient is a Hy. Okay. So A5 bar, A5 dot Ax is a minus sin phi and A5 dot Ay is a cos phi. Find that, as a phi is already know the 2 by 1, because the point is given 1, 2 and 3. 1 is a x and 2 is a y and 3 is the z. You'll get H bar is equal to minus 0.106 and Ax bar plus 0.053 Ay bar. Got it, my students? In 3 different cases we find the H bar is equal to magnetic field strength for the point given 1, 2, 3, and the different cases of the Z is we find as infinite. Z is equal to minus infinite to infinite. In other case, Z is equal to phi 2 in 0 to 5 meters, and another case is a phi to the infinite. Okay. Coming to the next example, find the magnetic flux density, means B bar, at the center of O of a square of sides equal to 5 meters and carry the 10 amperes of current. Okay, you see there is a plane with the point P here. What they are saying here, find the magnetic flux density at the center O of a square of sides equal to the 5 meters and carrying 10 amperes. Okay, 5 meters. 5 meters is the center, means definitely that is a 2.5 and the 2.5 is divided from the center, from A to B or the B to C or the C to D or the D to A, or it is a 2.5 to 2.5. X-axis is the direction of x-axis a positive, is the direction of x-axis a negative, showing that. and this is the direction of positive y-axis, and this is the direction of negative y direction. So it is a minus 2.5 and plus 2.5, and here the 2.5 and it is a minus 2.5. Got it, my dear friends? Okay. Then the point P is at the origin. This is the axis, x-axis. These are Z, Y, and the x-axis. This is a O. Got it, my dear friends? Now you can assume a differential element dx on the ax bar coefficient on the line of ax. So dl bar is equal to dx into ax bar. Dx into ax bar. Okay, and you can join from here a point 1 to the origin. The distance is r12 bar. So the origin is a 0, 0, 0. Okay. And another one is the point is at the dx r12 bar is equal to, so it is a x value. One thing minus x axy bar and minus y and the ay bar. The joining differential element at the point P we can take as of the saying the current is given 10 amperes and it is a meter of 5 meters is given. So there is a only the x and the y components under root of x square plus y square minus x into minus y ay bar, these are ay bar, sorry, and dl bar. What is the dl bar? Dl bar we can consider the dx into ax bar. Okay, whenever you can apply the cross product of dl and the a12 bar is ax ay az bar. The first you can take the dx because ax coefficient and there is any ay and the az coefficients, and in the a r12 bar also. For meanwhile, I am not writing the under root of x square plus y square. I'm taking only the ax bar coefficient is a minus x minus y and the 0. There is any z component. Okay. So ax bar is equal to ax bar into, you take the 0 into 0, you get the 0 value here, minus ay bar into these two values. You can take here also the 0 only, and az bar is taking off dx minus y into dx, having only the one component, this ay and the ax is the zeros. So dh bar is equal to idl bar cross ar bar. I take only the dl bar here. So I into idl bar cross we got as a minus y dx az bar, and in the denominator there is a 4 pi r12 square. 4 pi r12 square we already know that is under root of x square plus y square whole square. The under root of x square plus y square is a distance, and meanwhile I told that is a a12 bar. I am taking only the ax and ay coefficient, but here the under root of x square plus y square is also there, under root of x square plus y square. Okay. Now what is the current given? The 10 into y is also given, that is a minus 2.5 dx ax bar, not the x bar, sorry, az bar, and under root of 4 pi, the square root is get cancelled, and here the x square plus y square whole power 3 by 2, because here it is a power 1 and here it is a power 1 by 2. 1 plus 1 by 2 is a 3 by 2. Okay, and y already we take that is a minus 2.5 here. Y square is also minus 2.5 whole square, means 2.5 whole square. You can substitute here also the 2.5 whole square. Actually, it is a minus 2.5 whole square. That is a dH bar is equal to, we got as a minus 25 dx ax bar. Ax bar, since it is a 2.5 means 1 by 10 is a 10 get cancelled. And the denominator 4 pi into x square plus 2.5 whole square whole power 3 by 2. I can remove this differential h bar as the h bar is equal to apply the integral, and that integral with respect to the x values means x is taken as a 2.5 to the 2.5. That is from minus plus to the minus. Remaining all the functions is a constant minus 25 and the 4 by 5 is a constant. Write this as a 25 by 4 pi. And AZ bar also is a AZ bar, my dear students, not the x. And the remaining term is a 1 by x square plus 2.5 whole square whole power 3 by 2. Okay, if you get in the numerator, otherwise you can write the from minus 2.5, the 2.5 is a 2 into 0 to 2.5, or directly you can apply the integral, my dear students. Nothing will happen, sir. Now I'll change as put x is equal to 2.5 the tan theta. Tan theta is equal to x by the 5, x value and the 2.5, and the dx is equal to 2.5 secant square theta d theta. You can change the x limit to the theta limits. 2.5 is 45 degrees will get, and x is equal to 0 degrees. Why it is 2x is equal to 2.5 means tan theta is equal to x by the 2.5, and the 2.5 by the 2.5 is a 1. So tan inverse 1 is a value is 45 degrees. Okay. Now substitute that values, changing the x values to the theta values. You'll get to 1 by secant theta d theta ax bar. 1 by secant means a cos. The integral of cos is a sine 0 degrees and sine 45 degrees, sine 0, 0. Sine 45 is a 1 by root. And simplify the function. You'll get h bar is equal to 0.450 AZ bar, amperes per meter. And total h bar is there, the 4 sides. This h bar is due to the segment of AB of the square. All sides will produce the same. H bar at that point is a 4 h bar, 4 into 0.4501 AZ bar. You get the ampere per meter. Got it, my dear students? Otherwise, by using the formula, we can take whatever we did in the previously, alpha 1 and alpha 2. As in the alpha 1, opposite side is a 2.5, and it is also the 2.5 one, because it's the same thing from point P to the x value, or the P to the y value, or the P to the z. So I by 4 pi r into sine alpha 2 minus sine alpha 1. 10 is a given of the current. 4 pi into r will have 2.5 on. Okay. Then after sine 45 degrees minus of minus sine 45 degrees, both will get tan alpha 2 is a 1, because what point below, let us take here. This I am taking is a 2.5. So alpha 1, what is alpha 1 is equal to tan inverse of opposite side is a 2.5 and adjacent side is a 2.5. That is a tan inverse 1. Nothing but is a 45 degrees on. But alpha 1 I am taking here, they take here the minus, because the point P below that value is there. So negative values. So minus 45. Alpha 1 is below the point P. And similarly, the alpha 2 is also the tan inverse of is a 2.5 and the 2.5. That is also 1. Tan inverse 1 is equal to 45 degrees. Alpha 2 is a 45 degrees and it is a plus because it is above the point P. Got it, my students? So I is a 10 and 4 pi R is a 2.5 and sine 45 degrees minus of minus sine 45 degrees is a plus 1 by root 2 plus 1 by root 1 by root 2 plus 1 by root 2 is a 2 by root 2. Got it, my students? Root 2 plus root 2 by the 2 here. If I take the root 2 as a common, 1 plus 1, 2 by root 2. Then after you can simplify the function, the 0.4501 ampere per meter. Okay, this is an easy way to find the h bar, the total function, and then you can multiply the 4. Important is as the BC segment is not along the z-axis while using the formula derived earlier, do not use the direction as A5 bar. Remember that the h bar direction is normal to the plane containing the source. In this case, the square is xy plane normal to the which AZ bar. Hence, the direction of h bar is AZ bar. See, this is according to the Fleming's right-hand thumb rule. Okay. H bar is equal to 0.45 we got, and multiply the total h bar is a 4 into h bar, 1.8 AZ bar. The previous case also will get the same thing. It is a simple way to find the h bar for the given data. Okay, my dear students. The next one is next example. Find the magnetic field intensity at point P. Find the magnetic field intensity at point P for the circuit shown in the figure. So only you can find the magnetic field, the h bar is equal to at the point P here, the 20 meters length and the current I is given the 10 amperes and with the radius of 5 with a semicircle. So at point P, you can consider this as a point P is a midpoint of this distance of 10 meters, means divided as a 5 and the 5. Alpha 2 is above the point P. Alpha 1 is below the point P. Okay, so tan inverse, the R is given is 20 amp meters. So tan inverse alpha 1 is equal to tan inverse 5 by 20. So that alpha 1 is equal to tan inverse 1 by 4. And it is a minus value. Alpha 1 is equal to, you get the minus value. And alpha 2 is equal to tan inverse, opposite side is a 5 and adjacent side is a 20 only. And is a positive value. Alpha 2 is equal to positive. Alpha 1 is a negative because it's a point below. Got it, my dear students? Then what is alpha 1 and alpha 2? You see the alpha 1 is a minus 14.036 because it is a negative. And alpha 2 is equal to 5 by 20, it's a 14. Okay, because it is the semicircle, but the right hand thumb rule will get the minus z bar, sine 14.306 and sine of minus 14 point means sine of minus theta is a minus sine theta. You will get the plus. Okay, and the AZ bar minus term is there, the minus 0.0193 AZ. Okay, and the R, the radius given the 20 meters totally. Got it? The second section, consider the section BC in this 7.24. See in this denominator here only. The alpha 1 point B to the C. alpha 2 is equal to the 0 considered, and as a P alpha 1 only will get 75.96. Then after you can substitute the 0 degrees. Then another one in the section 3. So divide these as a 3 sections, as if I find the value, so one section here and another section here, totally the 3 sections. The second section we got as alpha 2 is 0, and in the third section we considered as only the semicircle here, only the semicircle, that is a CDE, and previous case that is a PBC, P, B and the C is a value P, and the considered is a point P only, is one, and the C value. Now it is a CDE, the semicircle totally. I is equal to, because it is I by the actually the 2 pi r, as a circular loop it is given as I by 2r. Is a formula is also, we already derived the expression, my dear students, A n bar. Okay. Let's substitute that values. We'll get the 10 by the 4 into 5. R is a 5, my dear students, and minus AZ bar. Okay. Minus 5 AZ bar ampere per meter. And section EA, only that we can take the section EA value. Here the point A, point B, and is a point A. Now if I'm taking only this value, EA is exactly similar to the second BC. So if you tag it is a BC value, now I'm taking this section. It's totally the first section is one, second section, third section, and it is a fourth section. When we consider these are 20 meters and is a 10 meters, it is a divided as a 5, and here it is a 5, the point P. The first section we can find here, and the second section, and is a third section, this is the second one, second, third, and the fourth. Fourth is similar to the second of BC, 0.1544. Totally the H bar is equal to H1 plus H2 plus H3 plus H4. Add all the terms. It is in the direction of AZ minus 0.8281. So first section we got let's see, this is the first section, minus 0.0193. Second section is a minus 0.15. Fourth section is also the same, but the direction is the difference. And here the H3 we got minus 0.1544. So take all the terms, is a minus is a common, 0.0193, 0.1544, and 1544, the both are the same, and 0.5. Total H bar for the given section, total section, H bar is equal to minus 0.8281 AZ bar. Got it, my students?